Hello and welcome back. In this tutorial, we'll continue creating schematic and PCB library, but the good news is this time the method is much easier than you expect. If you are new to the Altium free library loader, follow the link in the description and then you can join this video. So let's get started. As I mentioned in the previous video that you can how to download the free library loader for Altium Designer. Once you install your library loader, you can come here in the file, symbols, footprint, and 3D model. You can add or import. You can import from online database your footprint and symbol. Also, in the tools menu, you can find the very same tool. Okay, you can invoke either from here or from the tool menu. So you can open this dialog, this window, and you can log in. If you haven't logged in, you can just log in. You can create your account for free. Okay, so the focus will be again on this particular circuit. This we are discussing this since the very first tutorial with two fixed regulator and a programmable or adjustable regulator. So we created the schematic and PCB library for these guys, and that was quite a hard way. But now you can simply type in the part number here. For example, LM7805. I want to import this particular component, the symbol, footprint, and 3D model. So I'll just type in and search. Please make sure that your internet is connected, and now you can see that for that particular part number you have different options. For example, here you can see the symbol, then there is a you can just click them to open in a browser. Your symbol looks like this, and similarly you can click the footprint. Right, you can zoom in and zoom out to see the details. Okay, similarly you can also see the scale here. That's important to show you the dimension, and you can also view the 3D model of this particular component. So if you click, you can also open it, and you can uh, rotate it, rotate this 3D model. Okay, so you can search the other models too, the footprint and models, whatever best suits your requirement according to your circuit. You can just select that, but make sure you have opened a schematic file. Okay, here you can see I have opened my test schematic file dot schematic document. Okay, so once you have opened a schematic file, you can then use this information, this option, add to design, and it will take a while to download from the internet. I think I have already downloaded this, that's why it's asking some permission. Okay, so now you can see that, and the last message I just pressed OK, but the last message was that you can find your symbol at the bottom left of the schematic. So here is my schematic symbol of the LM7805, and one more thing you need to notice here, that another schematic and PCB library has been schematic and PCB library have been created. You can see here in the free documents folder. Here is the PCB library, and here is the schematic library. So if I double click this schematic library, I can find that particular the newly imported schematic symbol here. Similarly, if I double click the PCB library, I can see the footprint of that particular component here. Alright, so uh, since they are schematic in PCB libraries, you can you can explore different options. They are exactly the same, just like these guys. But the thing is, they are automatically imported from the database. Now, the reason I showed you in the previous tutorials how to create these footprint by yourself is that here you can play with it. You can make changes according to your requirement. For example, they have, let me go to the panels and property. So I cannot find the properties here. Okay, if I just click some double click here, I cannot find the properties, and if I cannot find the properties, that means that I cannot change those properties. So but here, look at here, let me open the one that I created uh, from the scratch, TO220, this one. Here you can see that if I want to change the properties, just I click this guy and you can see that I can change its properties. Okay, so now if I want to add any of these symbols or any of these footprints to my library, all I need to do is to just copy and paste it there. For example, I want to copy this footprint. I'll just select all, press copy. Before pasting there, I need to click here somewhere that sets the reference, and here, for example, I want to replace this guy like this. Now I have pasted the one that was created, that was imported from the library loader. So you can see that the it's much similar, and if I put them much closer, the distance and everything is almost the same. But the thing is, I have left rather little space for the soldering. Okay, you can see that white portion, while here we got rather more space because they have set this to 2.055, while I have set this to 2, and the hole size I have used is 1.5 and they have used 1.37. So I can keep that hole size, but I can, let's say, if I'm interested, I can make this 2.1, and similarly here 2.1. So that will give me more space for the soldering like this. Okay, all I need to take care of is the spacing between them, between these two pads. So I can play with these stuff only if I know about how to change the properties. If I know this thing, that's why we covered, and that's why we focused on creating from the scratch in the previous tutorials. So if you have something on your board, you can play with it and you can easily modify it according to your requirement. So now you can press 3 to even to see the three-dimensional view. Okay, and similarly you can press 2 to view the two-dimensional view of your regulator. Right. So that's how you create, and then you can import to you can add to your existing library like this. All right, I'm going to delete it for now. Similarly, I'll just save it, and similarly, schematic. Similarly, you can copy this schematic symbol, copy, and then you can move to your own schematic library, and in the schematic library, your here is the one that we have created from the scratch, and if we paste it somewhere here, okay, like this. So as we know, the size doesn't matter. All we need is the pin numbers at the right position, and that's it. So uh, if you already have have something on your editor window, you can easily modify these properties uh, to make it according to your requirement. All right. So similarly, we can import. Similarly, we can import the other components on the schematic. For example, we have, let's say, this variable resistor. Okay, we have this variable resistor, and for that, uh, let me first search it on the mouser.com. So let me need a trim part, and I'll just type in mouser to get there. So right, here we have different kinds of trim ports, and 500 ohm is okay. Then let me look for 10k. So I'll just filter here. I'll just click the 10 kilo ohm, and I'll apply filter. Okay, so right, so let me choose this guy here. Yeah, so I can add this one to my library. I can just copy the part number and then open this library loader, paste it here, and then search. Okay, so now I can just press the 8 to design. Alright, it says that this part is almost ready. You have 3 options. Okay, that means that it will take you to the Altium website where you need to go through some process. After that, you'll get this. But I'll suggest to search for a similar part. I mean, a similar package like uh, like this. This is also a 10 kilo ohm, and you can type in here. You can paste it here. Okay, so this one looks better. Uh, you can confirm the power rating, but here since we are using for adjusting the um, output voltage, So we don't need much higher uh, power rating in this particular case. So it's 500 milliwatt. 500 milliwatt is also here, so it's half a watt. That's okay for our application. So we can just add it to our design. Just press add to design. And once again it will take a while. Now it's creating the footprint and simple. Okay, please check the bottom left corner of your schematic to drag the component. The component is in the bottom left corner, and now we can drag it into the middle anywhere we want to use it in our circuit. So once again, this is added to our schematic, right? And these are the three terminals of the variable resistor, that trim pot, and we can see it here in the schematic library. You can see this is the schematic symbol, and also we can go to the library as the PCB library here, and this is the footprint. So just type in, just press 3 to see how it looks, but it's okay. The only thing is that the pads and the 3D model is not in the are not aligned. Okay, so we need to rotate this 3D shape in order to uh, make them in the right direction. But as I said earlier, since we are in this automatically generated PCB library, we cannot edit the properties here. So if you want to edit the properties, we need to take it to copy and paste into the uh, library that we created, that we have created. That's here, register underscore library. So I'll just copy, and again I'll choose a location here, and I'll bring it here. Now you can see that if I paste, here is my R0805 TO220. Similarly, this is the tantalum capacitor footprint. I'll add a new one, and then I'll paste it here. Okay, and I can name it. What was the name of this guy? It's 3296W 3296W 10K. 3296W 10310. That's for 10 kilo. So now we can edit the properties. You can see that property panel pops up. The thing is, in fact, the symbol that is imported here from the online database, from the that the library loader has imported, I personally don't like this one. Instead, I will prefer to use the one that I created. That's this one. This one looks much like a variable resistor than that one. So all I need to do is to figure out which of these is the variable one. Okay, so here is the one in the middle, that is pin number 2. We can use this guy and any one of these two, and by rotating that screw, you can change the resistance. So I'll keep it. I'll keep the same pattern, and just to confirm the pin numbers. Okay, this is pin number 1, this is pin number 3, and this is pin number 3. So I'll name it pin number 3, this one. We'll name it 3, and I'll name this one as 2. Okay, so this is the schematic symbol that I'm going to use, but the footprint that I'm going to use is the one that I imported from using that library loader, and I copied and pasted into my existing library, PCB library. So here I can now uh, now I can change the properties, and the first thing that I want to do is to change the view. Now it's in three-dimensional view, and as I said that in order to see the alignment, we need to rotate this 3D shape. So I'll just select and let me rotate this by 90 degree in the X direction. And where is the pads now? I just need to rotate also in the Y direction by 90 degree, let's say, and to see where it is, I'll just switch to two-dimensional. Okay, yeah, and now just take it to 3-dimension. As I see here that you can see this white line here because of the pins, the pads are in the center here, in the center. We need to add some standard height to this guy in order to make them visible, and to get that view of whether the pins are getting into that pads easily or not. So I'll just click that, and I'll add just some height of, let's say, 8 millimeter. So here they come, and I need to rotate this in the opposite direction, maybe in minus 90 degree. Alright, so now that's better. So now you can see that, and maybe even if the standard height is a bit lower, I can set that to 6. Now, yeah, much better. So now I can get a view of the bottom view, and you can see that it clearly shows that yes, the pins can easily get in there, and our footprint is right. Okay, so I'll just press 2, and I can save my footprint here. And just to confirm, okay, I have named it R3296W-103, and in the schematic library I'll add a footprint here, browse to, and press OK. Right, now I can save my schematic symbol. Okay, so now I have added this footprint. Okay, that this is the footprint that I imported from the library loader, and I copied and added and I copied that to my existing library, the one that I created. and then add it to the schematic symbol that I have created. Okay, and to confirm the footprint and symbol, you can further explore the data sheet of this component of this trim part, and here you can see that this variable register is available in a variety of footprints. Okay, you can see that the wiper is on the left, and you can also see this kind of we have used this the one that I have used here is this particular, and here is the pin numbers explained here. The pin number 1 is designated as the counterclockwise, and it's yellow. The green is labeled as clockwise, and you can use 2 1 or 2 3 to change it to achieve variable resistance, okay, by controlling this knob. So you can confirm from here. For example, let's confirm the distance between pin number 1 and pin number 2, that is 2.54 mm, and you can go to the library and let's measure the distance. You can place dimension and linear dimension, so you can from here to here, it's in the mils unit. We can change it to millimeter, and now you can see that the distance between them is 2.54 mm, and you can freely change the size. For example, if you want 1.3, if you think that the manual soldering that you will perform might need more space, so you can type in 1.3. So you can change these guys as well, 1.3 and 1.3. So you can edit these footprints when you import them to uh, your existing libraries, and I can close them like this. Right. So that's much better, and you can also add other features that if you like. For example, to make this very clear that there's going to be that this control knob. If you want to um, make it more clear, you can also put it in your on your uh, footprint here. You can just change to, okay, on the top overlay, and here you can insert a full circle. I just want to select the circle, put it somewhere here, and I can then further make it more clear by drawing a line like this. So this makes the picture more clear, that how to place your trim pot on the uh, PCB, how to place your trim pot on the PCB. So that's an indication for your PCB. All right, so we have successfully imported footprint and schematic symbol for a trim pot. Now similarly we can import the capacitors, the footprint for the capacitors, and for that let me go back to mouser and say I want some tantalum capacitors. Alright, so from here I can choose the voltage that I need. For example, this is 35 volt 2.2 microfarad. Since my input I have designed my input as 24 volts, so at least my capacitor, the input capacitor, should be at least 35 volts, and if I can find 50 volt, that would be much better. So I'll just search for 50 volt and I'll apply filter. Okay, so now that makes my job easy, because it gives me 50 volt options, and I can just go for the capacitance, and I can also filter that, um, but sometimes you need to go for manual work, uh, and let me make it 22 micro for instance. Apply filter, and now the package is, there is no SMT in this case, so I'll go back and change my let me for instance choose a 10 micro, and let's see. Apply filter. I need to change the input, the voltage. Yes, I need to lower my voltage from 50 to maybe 35. That would be better. Okay. And if I can now find something bigger, yeah, 47 microfarad and 35 volt. Oh, oops, even not, no luck even with this one. So I'll lower the value a little bit this time. Let's say 10 micro. Okay, that's easy. 10 micro and 35 volt. That's easily available. And if I want to use it, because I want to import it for my PCB, so all I need to do is just copy this part number, and then I'll paste it into, I'll copy this part number, and then I'm going to open in order to use this library loader, I need to open a schematic, and then I'm going to paste this part number. Okay, so here comes that part number, and now I can just add to my design by clicking add to design. Alright, but here comes the problem. This part is almost ready, and again that okay, I want to get into that, and I want another one that is ready for download from here. So I'll just choose another one, and let's see if this one is available. Oh, it's almost the same. It's the very same part number. So let me try. Okay, this one is available. So I can use this add to design. Oh no, no. Even this one, even this one is not going to help, and I need to keep searching for the one that has not only a 3D model but also has the schematic symbol and footprint. Okay, so that's what I'm searching for, one after another. So here you can see that now I got someone and who has the schematic symbol, the footprint, and the 3D model. So now I would like to add this to my, and but for that I need to confirm that whether it's 30 volt, okay, 35 volt, 10 microfarad, okay, that's the one that I need. So now again the very same message that it has been imported, and you can find it in the bottom of your schematic, and here is the schematic symbol, and to see you can come here, the polarized capacitor. Okay, this one looks much better, and then to the PCB footprint. This is the footprint that has been imported, and I can use this one as well as the let's for instance for adventure, that I want to use not only the schematic symbol but as well as the footprint. So I'm going to take them to my library. Okay, here I have created this polar capacitor, this symbol of polar capacitor. I'll just copy this one and paste into, I'll just use space to rotate. Okay, and I'll get rid of the one that I have created in previous tutorial. And you can see that the footprint that I have previously created is already added here. So I don't mind, I can add many of the footprints to this particular polar capacitor. So I'll let that stay, and I'll add the another footprint that I just imported here. I'll just copy this one, and keep in mind whenever you copy a footprint or a PCB, you can just select an area before pasting. So I'll just add a new guy here, and I'll now paste it here. And to name it, before naming I will get to that. Okay, it's 6032. I'll just name it, but before that I can check the data sheet of its data sheet. I can check this. Okay, so 6032-15, that's the casing of this particular let's uh, this represents the footprint of this particular tantalum capacitor. So I'll use that 60, yeah, the case code is 6032. So let's see 6032. I'll just name it like this, and I can even make it look better, but just by drawing a few more lines. This will not only make it clear to me during soldering that which side is the positive and which side is the negative. That is also something very important when it comes to capacitor and diodes. So you can see that this line is thicker than this one, and you can check from the properties. The width of this line is zero point 0.2, while this one is 0.254. You can press shift and select these new lines, and then you can change the width of all of these guys to zero point 0.2. Now you can see that okay, I just missed this guy. So yeah, you can make those fine tunings just by dragging these lines, because they'll just print on your PCB. No strict constraint on the dimensions. So you can use these uh, drag in corners technique to make it look better. Alright, so you can press 3 to view three-dimensional. Okay, if you feel that uh, the pad's size is relatively lower, and it will make trouble for you during the soldering, then you can extend its size. You can make it even wider. For example, you can make it to 2.7. okay, similarly you can select this one and you can make it 2.7. so this will give you more tolerance with your hand soldering. As far as the machine soldering goes, the one the footprint that you import is okay, but when it comes to hand soldering, you need some tolerance, you need some additional you need extra pad size, and that makes your job easy while soldering. So now we are done, and you can see that we have now some extra space on the left and right side of the uh, capacitor. Okay, so now it looks better. I'll just save it, and that's how I can develop my whole library out of this tool. That's called the Altium library loader. So you can use it and make your job easy. Okay, so with that said, I'll just sign out, and in the next lecture I would expect that you have created all of the schematic symbols and the as well as the footprint for all the components given here, and we'll just start putting dragging them and connecting them to complete a schematic, followed by the PCB routing. So just complete your PCB and schematic library, and we'll continue from the next tutorial. Till then, bye bye.